Hello everyone. This is a video presentation of fifth assignment of Mechanism Session. This video is brought to you by Vikram Rajendraprasad Kanaujiya, Ankit Meda, and Pritish Saha. In this
In this
video,
video,
we have
we have
discussed
discussed
about
about
the
the
problem of
problem of
a
a
problem
problem
statement.
statement.
The
The
problem
problem
statement is a
statement is a
windscreen
windscreen
wiper
wiper
simulation.
simulation.
We are
We are
here to
here to
create a
create a
simulator
simulator
for a
for a
windscreen
windscreen
wiper
wiper
mechanism
mechanism
without quick
without quick
return effect,
return effect,
visualizing the
visualizing the
wiper
wiper
area
area
and
and
allowing
allowing
adjustment for
adjustment
wiper
for
length,
wiper length,
motor speed,
motor
and
speed, and
angle.
angle.
The
In the
enhanced feature
enhanced
of
feature of
this
this
simulator
simulator
includes
includes
options to
options to
modify
modify
wiping
wiping
range,
range,
calculate
calculate
whipping speed
whipping
and
speed and
acceleration at
acceleration at
constant motor
constant motor
speed,
speed,
and
and
estimate
estimate
motor torque
motor torque
requirements while
requirements while
neglecting the
neglecting the
dynamics.
dynamics.
Now I
Now
will
I will
pass
pass
it over
it
to
over to
Pritish Saha.
Pritish Saha.
So, hello everyone. Now I would present the 4R linkage. So, a 4R linkage basically contains four revolute joints and which are basically connected by links, and this forms a closed loop which allows for different types of motion. There can be basically many configurations in the 4R linkage. There can be something called as a crank, means which allows full rotation, means as you can see that this link over here, it can do a full revolution, basically full rotation basically. So what if we are offering, means what the crank offers is that it gives a full revolution. And what is the difference between a crank and a rocker is basically a rocker is like a pendulum which can only revolve in about some angle, means it can have a maximum and minimum, means a maximum angle basically. So it cannot provide a full revolution, full oscillation basically. It's basically providing an oscillation. So a double crank is basically when there are two cranks basically. And how can we find out that whether this is a crank or a rocker? So what we can use is that we can use the Grashof mechanism, Grashof criterion, which is basically the shortest link, the length of the shortest link, and the length of the longest link. In the 4R linkage, if those two adds up and is less than the length of the links, other two links, then we can conclude that the shortest link can be a crank basically, which means it can revolve fully. Okay, so this is basically how we can find out whether the link which is there is a crank or a rocker. So in the next slide we can see we have basically provided an analysis which is a normal graphical means a normal complex analysis. We can do it with the help of complex analysis, or we can do it with the help of geometric analysis. What we have done is that for example we can go till for example how we can derive these relations is basically with the help of some geometry. We can find out this with the help of cosine rule, and then after using the cosine rule we can just simplify to find the means this gamma, which is this angle over here, and then to find the angular displacement over here, which is the theta 3 and theta 4. So how we can do that is basically we can use complex analysis uh, to basically go up to a certain point, and then we can use normal complex analysis to go up till this point and just equate it, and then we will get these relations. So after simplifying we will get these relations. So after this we would like use these relations to provide the viewers some simulation to get an idea about how the windshield wiper mechanism actually works. So the windshield wiper mechanism will actually work like a 4R linkage. So in the 4R linkage, as you can see, there is a crank and a rocker. So the crank can provide means a full revolution, and there are some rockers which can revolve, means provide a maximum revolution. So we can fully visualize the entire setup using our simulation. So to present the simulation, I would hand it over to Ankit. So
Hello everyone, my name is Ankit Meda and I'll be discussing about the simulator that we created. So basically the software that we used is Autodesk Inventor. We created different parts for the mechanism and we basically made joints and constraints to link it together. Uh, Also we use the dynamic simulation feature from the app itself, and let's have a look at the simulation. Okay. So as you can see, this is a mechanism that we created. We also give it a nice glossy finish. Uh, okay. Yeah. So now we are opening the dynamic simulator in the app, and this is how it works basically. It's a pretty neat mechanism. As you can see, there are different joints and nuts that we use to. I mean, sorry, bolts that we used. And okay, and next slide, please. Now I'll give it to Vikram to help explain the 6 hour linkage.
6 hour linkage. Just like 4 hour linkage, 6 hour linkage, also known as 6 bar linkage, is a planar mechanism consisting of six rigid links connected by six revolute joints, forming a closed loop. This type of linkage allows a more complex motion patterns compared to simpler mechanisms like 4 bar linkage key. Characteristics include six rigid links, six revolute links, closed loop configuration, most degree of freedom than a 4 bar linkage, capable of reducing intricate motion paths commonly used in advanced mechanism systems and robotic applications. The
The
additional
additional
links
links
and
and
joints
joints
in
in
6 hour
6 hour
linkage
linkage
provides
provides
greater
greater
flexibility
flexibility
in
in
designing
designing
mechanisms for
mechanisms for
specific
specific
motion
motion
requirements,
requirements,
but also
but also
increase the
increase the
complexity of
complexity of
analysis and
analysis and
synthesis
synthesis
compared to
compared to
simpler
simpler
linkage.
linkage.
Uh,
Uh,
so,
so
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 now
now
our
our
presentation
presentation
ends.
ends.
Thank you for
Thank you for
watching.
watching.